Okay. Hi, everybody. Thanks for joining us this morning for Beyond Crash Data, exploring new data sources to improve road safety. Looks like people are still trickling in, so happily we've got a couple of intro slides that people can catch up on later if they miss. Let's see. Just a couple of quick notes before we start. We'll be responding to questions at the end of the presentation, so please add your questions to the Q&A feature, and we'll get to them at the end. Also, the recording of the presentation and the deck that we're going to share will be available to attendees afterward, and we'll send an email to everybody who participates after the presentation. Really quickly, we'll do some intros. I'm Jonathan Lachance. I'm an urban planner with 4 years of experience providing government agencies with mobility and scenario planning software. And as head of market development for Vianova in North America, I'm focused on working with local and regional governments to help them use data to achieve better road safety outcomes. And I'll pass the mic to Jesse.
Good morning or good afternoon, depending on where you're located. My name is Jessie McGowan. I'm an associate at Sam Schwartz in Jersey City. I primarily work, I'm a transportation planner and primarily work on Vision Zero and safety action plans, as well as bicycle and pedestrian master plans. I really like to get into the data, so I'm excited to talk to you all about this a bit more today. I came to Sam Schwartz from Montgomery County, Maryland, where I worked with the County Planning Department on Vision Zero. So you can go ahead to the next slide. So today's presentation is going to focus on data analysis and different data sets that we can use as part of safety planning, but it's going to be done within the lens of the Federal Highway Safe Streets and Roads for All program. So Safe Streets and Roads for All, are also called SS4A, is a recent federal program distributing $5 billion over 5 years for planning and implementation of safety plans and projects with a focus on Vision Zero and the safe systems approach. It's funding that goes directly to individual jurisdictions like counties, towns, tribal agencies, et cetera. So it's funding that doesn't go through necessarily an MPO or a state in order to get to you as a local practitioner. You can get this funding to develop action plans, to conduct demonstration projects like short-term pilots, as well as for implementation projects, so like capital funding to build safety improvements within your community. Within this program, there's an opportunity for experimentation and deployment of new technologies. So through that demonstration projects and also through action planning, you can say, you know, we really want to test out this data set we've never used before. We really want to try this technology that our jurisdiction has never used in the past, and it gives you an opportunity to really pilot something new as part of this safety effort. So you can go to the next slide. And why is this important? You know, traditionally, we've really focused on crash data in thinking about safety, but the industry as a whole is moving towards a more proactive, data-driven approach. You know, crash data is inherently looking to the past to say what happened and how can we make changes, but we should also be looking to the future and thinking about how we can, you know, not just be reactive, but proactive in our safety planning approach. In addition, there's more data than ever out there, whether that's publicly available data, maybe data that your agency collects and maintains. And then there's also proprietary data that various companies are collecting that you may choose to purchase when you do your safety planning. And so there's a lot of options out there, right? Sometimes having too much data is almost more challenging than having enough. And so agencies need to be mindful in how they think about what data they want to use on different projects, what might be right for their community. And so that's what we're going to talk about today within the context of the Safe Streets and Roads for All program. So you can go to the next slide. So what are these different types of data? There's a lot of different options out there. Again, I mentioned crash data, right? That's really kind of the foundation of safety planning, looking at collisions and incidents that happened on our roadways. But there's lots of other data sets that we look at as well. So there's activity data. Maybe that's motor vehicle volumes and collection of AADT, average annual daily traffic. We could also have, you know, counts at an intersection of bicyclists and pedestrians, or built environment data. So maybe your GIS staff, if you have them, have data about your roadway network and the number of lanes or the speed limit, things like that. There's also qualitative data, which, incorporates feedback from members of the community. So what do we know about the lived experience? Maybe we're not seeing in these other data sets that there's a problem, but people really perceive a certain intersection or area to be unsafe. But there's also a lot of other data sets out there. The ones I just described tend to be more traditional, but through this webinar, we're going to talk about those, as well as other newer data sets that you can incorporate into your safety analysis. So you can go to the next slide. And why do we need all these different types of data, right? It's a bit, why can't we just use crash data? Why do we need to think about all of these different options? And how do we decide what makes the most sense for us? So first, we use this data to understand location trends among crashes. So instead of just pointing to crash history, we can use that built environment data or that volume data to say, maybe crashes happen on higher volume roads, or crashes happen in areas with a certain type of land use, things like that. Also, with some of these data sets, again, it allows us to take a more proactive approach to safety. So with looking at telematics or sensors, things like that, we can kind of better understand the behavior of people traveling on the roadway and ideally react before a tragedy happens. It can also help us prioritize areas for improvement, as well as be really up to date and current with the state of the roadway network and the state of behavior, right? If you are manually maintaining your roadway network in a GIS file, it takes some time between a project being completed and that data being updated in your GIS database. Whereas some of these newer data sets don't require that manual effort. They're captured more passively and in real time. And then also a lot of analysis typically looks at correlation, right? We say, where do things happen similarly, or where do we see that certain roadway conditions are similar or are aligned with the types of crashes that we're seeing, but we can't always get to that causation point. That's really challenging to get to, but some of these data sets allow us to get closer to that by understanding some of the behaviors that are associated with crashes and where those are occurring relative to where crashes occur. And then lastly, this data allows us to substantiate some anecdotal experience. So again, like I said, some people may say that intersection is really terrible, and the data can confirm that, or maybe the data doesn't confirm that, and we can try to figure out why that is. So you can go to the next slide. So we're just going to talk through each of these different types of data sets. Given the work that I do, I'm going to talk about some of those more traditional data sets that are really kind of the foundation of transportation planning and safety analysis. And then I'll pass it to Jonathan to talk a bit about more big data and this passive collection data that can really be an added value to your safety projects. So initially, here's crash data. This is the first one I wanted to speak to. This requires a crash report, right? This is something that a police officer is talking to the victims involved in a crash and assessing the conditions in which the crash occurred and entering into a database what occurred as part of that incident. That's a lot of manual labor, but that really is the foundation of most of our safety analysis. And if you're applying for any sort of grant for funding related to safety, you're likely going to need to report the crash history that you found. But as those of us that work with crash data also know, there's often a decent lag between when a crash occurs and when that data is available to the public or available to you as practitioners. And so that's just sometimes a challenge when we do safety analysis. I'm working on some plans right now where even the 2022 data isn't totally finalized. So we're looking at, say, 2018 to 2021, and that's kind of our best guess at conditions. So, while crash data is really valuable and it provides us a lot of insight into conditions on the roadway, it doesn't always tell the whole story. In addition, we only see in crash data crashes that are reported, whereas we know that some people that are involved in a minor fender bender may not call the police and file a report. Bicycle and pedestrian crashes tend to be underreported. And then also there's people who don't want to interact with the police. And so even if a crash occurs, they decide to go their separate ways with the other person involved in that collision. But then those of us that do this sort of analysis are really lacking in the full picture of what's occurring on the roadways. So you can go to the next slide. Another piece of data that we use frequently in safety analysis is understanding the built environment. Again, this may be speed limit, number of lanes, looking at the bicycle and pedestrian network. And it really helps us understand what's the conditions. is there a sidewalk? Is there a crosswalk? Is there a traffic signal? And it helps us better drill down into what types of locations are likely to result in a crash. And if you're, a public agency practitioner, you know that this data is often very inconsistent, or it's very difficult to have complete data. Again, right, if a new sidewalk is built, is someone going into your data set or asset management system to record where that is so that those who are doing safety analysis can then incorporate that into their understanding of where there might be a risk of pedestrian crashes. So while this data is traditionally manually recorded, there are some new technologies that Jonathan will speak to that allow us to collect some of this information in a more automated, efficient way. Let's go to the next slide. Another common piece of data is traffic counts, or looking at volumes or activity. This helps us understand how risky it is on a given roadway relative to the amount of activity or vehicles on that roadway. So, for example, maybe we have a street that has a lot of crashes, but it also has 20,000 vehicles a day. If we have a similar street that has the same number of crashes, but only, say, 2,000 vehicles per day, the risk on that lower volume street is much higher. And so looking at traffic counts helps us contextualize the crash data and better understand, what are the conditions that are going on in that location. In addition, traffic volumes can often serve as a proxy for built environment data. And I guess the same is also true, that built environment data can sometimes serve as a proxy for traffic counts. But a lot of times we see that crashes happen where people are, where people are walking, biking, driving. If there's no one there, there's not going to be any crashes. And so this is just a helpful way to contextualize why it is that a location may have a high number of crashes. However, this data is often collected for very short periods of time, say, a 2-day period, or even just during the peak hours of a 1-day period. And then we tend to try to extrapolate that for long periods of time, which can result in errors because we have to make quite a few of assumptions in doing that. So you can go to the next slide. We also often look at demographic data. This can allow us to better understand, again, the context in which these crashes are occurring. Is it occurring in a very affluent neighborhood? Is it occurring in an area that is largely people of color? What are we seeing? Is there a correlation between the types of places in which these crashes are happening? And the data we use for this tends to be the US Census, or the US American Community Survey. But I think a shortfall of this data is that it really focuses on where people live and not where they travel, right? So if you get in a traffic crash, it likely isn't right in front of your house. Maybe it's in your neighborhood, but we base a lot of this analysis based on where people live, but we know that they're traveling all over. So kind of all that we can really say when we do this sort of analysis is that neighborhoods with a high concentration of low-income residents or people of color have more crashes. That's not necessarily saying that people of color and low-income people are involved in those crashes, but maybe they're at a higher risk because crashes are happening in their neighborhood. And we use this data generally to understand if there is a disparity, if there is an equity issue within, a jurisdiction, but then also we use it when we're identifying projects to say, okay, we want to make sure that we're leveling the playing field through our efforts and that we are reducing any disparities that we've found. And Safe Streets for All, as well as, many federal highway programs under the Biden administration, really have a strong equity focus. And so I imagine that this is the sort of analysis that you would want to do as part of any grant application or just as part of your analysis more broadly. So you can go to the next slide. Lastly, I'm just going to talk a little bit about public engagement and qualitative or anecdotal data. Right, we know that numbers can only tell part of the story, and it's really important to also understand the lived experience. So through focus groups, public meetings, different mapping exercises, it's really an opportunity for members of the public to share what they see as problem areas in their community or areas that they feel safe walking, unsafe walking. Because again, while we can look at the numbers and we can look at the research, a lot of this is right. This is all about people. And even if we put in all of these treatments and people still don't feel comfortable walking, we've missed the mark. So we want to really understand, what is it that needs to be done in order to create an environment that people want to travel and feel comfortable traveling. I also, I haven't kind of talked about this throughout, but I think while I'm a transportation planner, I do technical transportation planning. there's politics in everything that we do. And I think that being able to demonstrate to decision makers that maybe a large percentage of people who responded to your survey or were in your focus group saw this location to be an issue, or see that safety is a priority that's not sufficiently being addressed in their community, can be a really effective way to move the needle with your elected officials and decision makers as well. So now I'll pass it on to Jonathan to talk about some other types of data.
Thanks, Jesse. Okay, so telematic data. Telematic data is data generated by detectors installed in vehicles or by devices such as smartphones that are enabled to detect driving activity through apps. What's most exciting about telematics is the range of insight they can provide. They basically transform cars into nerve centers for road networks by tracking aspects of driver behavior like speeding or harsh braking, as well as crash data, road condition data, and more. Because telematics are being produced more or less constantly, they can provide very granular insight into what's happening with a range of vehicle types while they're using your road network. So this means you can get updates on aggregated driver behavior at your preferred frequency. Sensors and camera data. There are a range of cameras and sensors out there that use technologies like LiDAR and AI to track the movements of vehicles, detect and count the different types of road users and use patterns, and observe and report on incidents such as near hits and crashes. These sensors upload their data to the cloud, enabling transportation planners to track activity at key intersections in real time or in historical data sets. However, because this is expensive equipment, it's advanced, but it's quite costly, it might not be appropriate for deployment over an entire road network. Instead, these devices are best for corroborating telematic data or observations at key intersections, or for identifying the causes of events like crashes. So activity trace data, like telematics, this data is produced by internet-enabled wearable devices like phones and watches. This data is aggregated and anonymized and can be used to create a more complete picture of where and how pedestrians and cyclists are moving. And I'll explain how this can be particularly helpful for assessing road risk later. Now, I'm not going to make you all read this summary chart while I talk or try to read it to you. You'll be able to access this info later, but it provides a quick comparison of the strengths and weaknesses of the different kinds of data we just discussed. It's important to note, I think, that the biggest change between the traditional approach and the safe systems approach isn't just that you need more data, but like Jesse's been saying, it's about getting smarter, more timely data to help you understand where risk is before crashes happen. How old is the crash data you're using? When were the traffic counts taken and where? And what were the mitigating circumstances? Even the most proactive manual data collection efforts can provide laggard and incomplete data because people can't be everywhere at once. So transportation planners still need to be able to keep tabs on what is changing on your road network now. Also, not all data can be comprehensive, right? It's a big lift to track everything that's happening every second across millions of actors or thousands of miles of road. And of course, some metrics like demographics don't change fast enough to warrant real-time monitoring. But as new data streams become available, planners can access more timely intelligence and reduce their reliance on smaller sets of data collected by in-person observation. All that said, not every road safety pro will be able to access or use all the data all the time. The two biggest constraints for planners are usually funds and program maturity. Here we've attempted to show where different kinds of data fall along both of these axes. Traffic volumes, public engagement, data on the built environment, and crash data are usually free and available to traffic planners and are a great starting point for building up your baseline understanding of road risk. The real-time data provided by devices tends to be more expensive, and planners need to be able to act on the insights it provides, which is why it's farther out and up on the graph. But the good news is that SS4A is specifically designed to help cities build their safety planning capacity and deploy these new technologies. So next, we're going to walk you through a couple of actual case studies exploring how both Sam Schwartz and Vianova have used different layers of data to get better insights and outcomes from the road safety work. So Jesse, I'll let you lead it off.
Great, thank you. So in my former role at Montgomery County Planning Department in Maryland, we worked on a project that we called the Predictive Safety Analysis. And what we did through that effort is that we combined a bunch of these traditional data sets. So we looked at crash data, built environment data, and traffic counts to develop safety performance functions, or SPFs, essentially equations or algorithms to estimate how many crashes were likely to happen at all the intersections and segments throughout the county. And what was useful about this effort was that in addition to understanding, where crashes have happened in the past, this also pointed us to some locations that are in kind of the top left quadrant of this chart you see here, where we found that there was a high risk of crashes, but low observed crashes. And these are places that, for one reason or another, have not had a high incidence of severe injuries or fatalities, but our analysis shows that they are very risky. And so this is a place in which we can really be proactive in making improvements before tragedy strikes. So this effort allowed us to prioritize locations for different types of safety treatments and take that kind of more forward-looking approach by compiling a bunch of different types of data to understand not just crash history, but crash risk. And I'll pass it back to Jonathan to talk about London, I believe.
Thanks. Yeah, before I go into Vianova's case study, I want to provide a little bit of context for those of you who might not be familiar with what we do. So Vianova has a software platform that can ingest any kind of data stream to support a range of mobility use cases. As it happens, the use case we've been laser focused on for the last year is road safety. We created a data product called RiskAware to help cities or other government agencies take advantage of all these amazing data resources. As mentioned earlier, crash data is an important but small part of the picture of risk. It's the noisiest and most attention-getting, but each fatal crash is just the tip of an iceberg of hundreds of thousands of unsafe acts. That's why RiskAware consolidates multiple data points, including telematics and other risk factors, to help proactively monitor risk as it evolves. RiskAware works by combining a range of risk factors into a consolidated score for each segment and intersection in a road network. And since no two jurisdictions are the same, we can customize the data mix and weighting to reflect local priorities and context. We can provide this data at the city, county, or even state level. This lets our customers identify the riskiest roads and intersections in their road network, factor in other criteria like demographics or pedestrian density to help prioritize where to intervene, and then track the impact of those interventions over time. Here you can see our dashboard displaying the most dangerous roads in London and the tooltip summary of a particular road segment in London. Sorry, I'm getting over a cold. So. We recently put RiskAware to the test with the City of London. TfL, Transport for London, wanted to understand the impact of speed limit reductions on driver behavior. They also knew that trucks were a risk factor for vulnerable road users and wanted better insight into where those two user groups were converging in order to identify alternative routes for both. Using telematic data, they observed that their speed reductions were incredibly impactful, resulting in an average 9% year-over-year reduction in average speed. By collating truck-specific telematic data with bicyclist flow data, they were also able to discern locations where they needed to better separate bikes and trucks to ensure better safety outcomes. TfL's work is ongoing, and with RiskAware, they will be able to monitor the impacts of future interventions on a rolling basis. So, Jesse, do you want to wrap it up?
Sure, thank you. You can go to the next slide.
Sure.
Yeah, so just in sum, there's lots of different types of data out there. If you're doing any sort of safety analysis, I'm sure you're looking at some of those traditional data sources, but there's also an opportunity for you to look beyond those to be a bit more creative and targeted in how you're thinking about safety in your community. So, not all data sets are well suited to all projects, given the size of your jurisdiction, how long you've been doing safety planning, and kind of the analysis you've already done. What you choose to do next may differ. I think the example Jonathan just gave about, you're really interested in truck traffic or, where people are walking and biking. Some of that is a bit harder to pull from traditional data sets. So you may need to kind of look beyond that to sensor data, telematics data, additional information in order to really answer the safety questions that are most pressing in your community. So while traditional data sets can serve as a baseline, maybe they're just a jumping off point for potentially using other sorts of data as you dig deeper into the emphasis areas or safety issues you've identified. So this is really all food for thought for those of you that are interested in the Safe Streets for All program and ways that you can put together grant applications to really best serve your community and identify safety strategies and safety data that can get you that Vision Zero outcome that you're looking for. So I'll let Jonathan, I guess, wrap it up, but we'll turn to Q&A and see if there's anything you all want to chat about.
So let's see, we've got, it looks like more comments than questions, but we'll engage with them anyway, because I think it's worth putting all these points of view out there. So somebody commented that Federal Highway Administration has been saying for 20 years or more that conventional intersections have 10 times the fatality rate of modern roundabouts. If you want to stop killing people, stop building conventional intersections. Good point. I don't know, Jesse, do you want to speak to that at all?
Sure. Hi, Ken. I guess I would add here that I think that maybe in a given community, you may still have work to do to make the case that this national research applies to you. And so maybe there's an opportunity to study any roundabouts that you have in your jurisdiction relative to the more conventional intersections, because I think sometimes people say, well, that data was done in Portland and we're not Portland, or that data and analysis was conducted at the national level, but I just don't know if that applies to my jurisdiction. And so, while I don't disagree with you by any means, I think sometimes what it takes to sway members of the public and elected officials is to really kind of replicate what we've seen on the national scale or in a different community in your backyard.
Thank you. Let's see, we've got another comment here. Underreported crashes and crash data. Is there a rule of thumb for the percentage of crashes unreported? Is this known to be more prevalent in remote or rural settings? That's a really interesting question. I don't know, Jesse, do you have any insight into that?
Yeah, sure. I wrote something in the chat as well
Okay.
for you all to read. But in addition, I guess I would just say that the question that's most of interest to me is not so much how many crashes are missing, but what types of crashes are missing, and are they different from those that we've captured in the crash data? So if the missing data was going to point us to the same intersections and corridors that we were already planning to improve, then maybe it's not a big deal that we don't have the full world of crashes. But I think that's likely not the case, and that by missing a lot of more minor bicycle and pedestrian crashes, by potentially missing crashes with people who are less comfortable calling the police when an incident occurs, we may be missing critical areas that are in need of safety improvement. So I'm not sure if there is a rule of thumb, but I haven't come across one in my work.
Yeah, and then an anonymous attendee pointed out that if no one is there, there are no crashes. And Jesse, you answered that talking about single vehicle crashes. I also think it's interesting that you can observe an area when you're looking at telematic data. One of the things that we've seen is that you can see a high degree of risk and low pedestrian presence. So it would seem at first glance that there isn't much of a concern for vulnerable road users, but if you dig deeper, sometimes you'll find that those locations are avoided by pedestrians precisely because of the obvious risk. So sometimes you're missing holes in your pedestrian network that can be revealed by looking at telematics and seeing where cars are driving like crazy. If you see a location that's a standard intersection and there's a lot of high-risk behavior, but almost no pedestrians there, that might indicate that there's insufficient infrastructure to support a safe pedestrian environment. It looks like we have another question that just popped in. Let's see. Great to see the impact of the speed limitation work in London. What are the next steps or data types that you're planning to investigate in that project? Oh, that's Matt from Viva City. Thanks for jumping in, Matt. That's a great question. I'm not personally working on that since I'm focused on North America. I'd be glad to put you in touch with the folks on the team who are working on it. I think it's longitudinal work ultimately, so they'll be tracking the impacts on bicycle movements, pedestrian movements, and truck behavior as they continue to identify opportunities to either put a fortified bike lane in or reroute bikes or reroute trucks. So that's something that we'll be posting more content on our website about as new information is discovered. And then we have another question from Jason. Thanks for joining, Jason. What are the opportunities to understand these data provided by telematic data based on the infrastructure? For example, being able to understand if someone was traveling in a grade separated bike lane versus shared lane, et cetera. That's a great question. So, in our platform, we can certainly layer in information on the type of bike lane if you have that kind of data. So we already map bike lanes pretty extensively, but we can create sort of custom road networks specifically for the subset of your road network that is a bike lane. So if there's subtypes of bike lane, if it's just shared or if it's separated by plastic bollards or if it's completely fortified, we can identify that, and then we can start to analyze where bike behavior is different based on the kind of bike lane that you've got, or where there's a change in risk based on the presence of those kinds of pieces of infrastructure. Let's see. Any other questions, folks? Oh, we've got another one. All right. Some designers apply highway fixed object concerns in urban environment streets. Any thoughts on how the data can speak to the risk of crashes with fixed objects versus crashes motorist to motorist, or motorist to VRU? How can we tease out design focuses through analysis? That's a really good question. It's something that I think, Jesse, do you want to take a stab at it? And I have a couple of notions, but this sounds like it's up your alley.
Yeah, sure. So I think that what you can do here, right, like is within your crash data, you would know which crashes are single vehicle crashes versus which involved another motorist. That's a pretty common attribute in the crash data. And then you can look at whatever built environment data or volume data or these additional data sets, whatever you have available to say, how are the places in which fixed object crashes are different than the places in which, motor vehicle to motor vehicle or motor vehicle to bicyclist or pedestrian crashes. Like, how are those locations different? And, the types of treatments that you're going to implement if what you're seeing is a lot of single vehicle crashes are going to be different than if you're seeing a motorist hitting a pedestrian or another vehicle or something like that. So that is a helpful thing to tease out when you're thinking about how do we reduce this type of crash from happening in your community?
Absolutely.
Go ahead, John.
No, it's okay. We've got another question. I'm seeing car crashes in the US being referred to as a public health crisis more and more. In your experience, is this lens a way to improve roadway, ped, and bicycle safety? Have you ever used health data to inform your crash analysis? That's interesting. Yeah, I mean, in terms of the narrative around improving VRU or vulnerable road user safety or reducing crashes overall, I think framing it as a health crisis does shift the narrative. But I don't know, have you seen that have an impact on like kind of the messaging side of things or the storytelling side of things when you go to a city or a jurisdiction and you're presenting data or you're working with the city on it when they shift the focus from drivers are bad to this is a public health crisis? Do you see a change in how people receive the messaging, Jesse?
Yeah, I guess I'm not totally going to answer your question, but I will reflect on the question that was asked in the chat a little bit. And I think that, the transportation industry and transportation planners have been learning a lot from the public health field. I think the public health field has done a better job of thinking about the systemic and like broader things that contribute to public health crises beyond just individual behavior, right? Like part of the safe systems approach is that everyone makes mistakes, right? We'd love if no one looked at their phone while they drove and if no one drove above the speed limit, but we know that people are going to do that. And so what we need to do is create a transportation environment that still, that accounts for those mistakes and that reduces the severity of crashes when those mistakes do occur and lead to a crash. And so the way that the public health field is really framed, thinking about, challenges in public health, is that systemic framing, right? Like beyond individual behavior, what do all of these different parties need to do in order to create an environment in which people make better choices. And when they don't make good choices, how is that environment, supportive or flexible enough such that they're, that it does, I can't think of a public health way to say this, but for transportation that doesn't result in a severe injury or fatality. So I think that's kind of part of why public health is being brought in. And I think it's also a public health crisis because 40,000 people die a year in the United States from traffic crashes. And we see that, I think, that's like maybe the second highest cause of death after gun deaths or something like that, or they're kind of neck and neck. And so I think there really is, if we're thinking about, mortality and how to just improve the quality of life and health of, people in the United States, thinking about transportation and traffic safety is a really important piece of that.
Absolutely. Okay, another question here that I'm happy to answer. With more and more connected vehicles and scooters on the road, is there an opportunity to collect more real-time data that would indicate a crash happened? That's a great question. So, yes, connected vehicles will often be able to indicate that there was a crash. They'll have sort of the car equivalent, I guess, of a black box event recording where they'll be able to talk about all the moving parts that were involved in the crash. And then scooters, some scooters can be equipped with telematic devices as well that would detect things like tipping over and crashes. With the challenge, I think, with using telematics for crashes is that it's sample data, right? Because the best data out there covers a significant percentage of drivers, but not all of them. So you're going to miss a lot of crashes, and it can certainly show you, again, it can be used like those other telematics to enhance our understanding of where there's risk, but it's not going to fill in all the gaps left by unreported accidents. You could compare, the kind of high injury network data with that telematic data to see where there are real discrepancies and then dig in from there. But unfortunately, it's not going to give you the absolute complete universe of crashes. Let's see. Another aside. Thanks for reading aloud my comment in for Jesse's most excellent hot tip on how to overcome local roundabout hesitancy. Right on. Cool. Let's see. Oh, okay. Another question. Reducing fatal and severe injury crashes is often framed as a difference in approach and priorities between state roads, DOTs, and municipal roads that often use Vision Zero branded approaches. Are there best practices or evolving strategies for helping different infrastructure owners find middle ground to reduce these crashes? That's a really interesting question as well. Jesse, do you want to kick it
Hi,
off?
Dan. Great question. Yeah, I mean, I think this is a big challenge, right? Like in any given community, there's going to be roads that are under the jurisdiction of different agencies, whether that's, the state, a county road, local road, et cetera. And I think, each of those agencies may be in a different place on their safety journey and what they see as a priority and how they think they can most effectively reduce crashes. I mean, I think kind of just beyond ongoing coordination and collaboration, I don't know that I have a ton of insights here, but I think ensuring that localities are involved in, developing the statewide guidance can be helpful. And then also, ensuring that the state or counties are involved as local jurisdictions are doing their plans can kind of reduce some of the friction between those different organizations.
Yeah, and I'd even throw this out there. I'd be so bold as to say that, data can be the great balm that unites the state and locals, because if you're looking at data that's mapped on a road network that doesn't differentiate between state roads and local roads, you'll be able to see how risk kind of has ripple effects from one type of road to the next. You'll be able to see the continuation of risk, for example, from a highway exit onto a service road into local roads. And you can start to see those patterns of risk and how they fan out, which can lead to some conversations about how you can find interventions at those kind of junctures of local and state infrastructure. Looks like we have another question. Are cities leveraging their authority to extract more proprietary data from all the sensors floating around? Is the data collection and metadata standards coming together to help the industry make sense of the big data world we live in today? So that's a couple different questions in there. I think in terms of the cities leveraging their authority. Yeah, so we know that as, it's interesting that it really depends on what governing body is governing the vehicles in question, right? And so as far as like the kinds of telematic data we provide, that's data that's, that's sourced from, it's aggregated from a number of different sources. So cities can choose to buy it. It's not necessarily forcing operators to provide it. We know that, in cities that have scooter and shared bike programs, they are requiring the data from those vehicles. And of course, there's a move to get, delivery companies to share their data as well. That's an ongoing effort, with the CDS data standard. But as far as the proprietary data, yeah, it's usually purchased from third-party providers. And whenever there's a fleet deployed in a place, that is an opportunity to require the fleet operator to provide that data. Where I am in San Francisco, we have an ongoing struggle with self-driving cars where it's actually a state authority that governs those, and local jurisdictions would very much like to get their hands on those telematics, but it's up to the CPUC, the California Public Utilities Commission, to force them to provide it. So that's kind of a point of tension. But I think there's certainly, I would love to see more data sharing requirements and cities empowered to get those data points from all kinds of operators. Jesse, do you want to speak to that at all?
No, I think you covered it.
Cool.
Thanks.
Let's see. Well, we're coming up on time. This has been great. I'll give just a few more seconds for anybody who wants to pop a question in here. But if not, I want to thank everybody for joining us today. I want to thank Jesse so much for all of your work on this. And yeah, it's been fun. And like I said, we'll be sending out a follow-up email to everybody who attended. And we're happy to answer any questions that crop up later. So yeah, thank you all very much for joining today. And take care. Be safe out there on those roads.
Thank you. Have a good day.
Thank you.